really quickly, I want to put into perspective of where cloud security and virtualization stand as we have for modern hardwares. So for this, I have this slideshow that should be 5 minutes. It's a non-comprehensive history of how hardware-based security evolved and where we are actually standing today. So now we are actually going to deep dive into the matrix. So you might know that before 82, what we had is really just physical memory that now we call the real mode. Of course, before 82, this is like the beginning of Intel, for example. This was just what you had. So you had an application that was running on your system that had access to your physical memory. And if you had multiple applications, those were running in the same environment and they would have no barrier in between. So if one application was misbehaving, there was nothing in the hardware to stop it. In 82, protected mode was introduced that actually brought with it 4 protection rings. So these are called rings, but of course these have nothing to do with the geometric rings, so I'm just going to use a box to represent them. And to confuse things a little bit more, privilege goes down. So the most privileged one is ring 0, and that's where your operating system lives. And there can only be one operating system, of course, so you only have one process running in ring 0. And then on the top you have, in ring 3, you have your application. We have also ring 1 and 2, but those are really unused. They were available, it's just, who cares? And as I said, privilege goes downwards. And again, we have more applications. And the way to think about it is that we have more boxes on the top. So those are actually living in what's called virtual memory. They don't necessarily see each other unless the operating system permits them to interact with each other. And they interact with the operating system, what's called system calls. In 2003, of course, we started looking at virtualization, and one of the virtualization mechanisms was Xen. And the best thing about Xen was that it was actually using the hardware to push the operating system down into ring 1, and that enabled the operating system to use the native instruction available in hardware instead of using something like emulation or binary translation. And that also enabled more than one operating system to run on the same hardware. So Xen would take the the space in ring 0, you have your operating systems in ring 1, and on top you have the applications inside each virtual machine. Unfortunately, in 2003, 64-bit mode was introduced by AMD, which actually disabled ring 1 and 2. So it wasn't that it wasn't used anymore, it was actually disabled by the hardware. So of course, that kind of presents a problem for Xen. So what they decided to do, they just pushed the operating system down to ring 3 as well, and then just use a software-based separation of the operating system between the virtual machine and the application. This is, of course, very slow and not as secure as the hardware-based mechanism, but hardware-based virtualization was introduced in 2006. So this is the VTX extension on Intel and the AMD V on AMD, where you actually have a ring -1 specific for the hypervisor. Then, depending on what operating system you're using within the virtual machine, ring 1 and 2 might be disabled if you are running 64-bit operating system, or it's just unused if you're running 32-bit. Of course, ring -1 is not really a ring -1, but that is actually a completely parallel mode containing another 4 rings. So things are going to get a little bit more complicated, so I start color coding here. So now on the left we have, with red, you have the hypervisor, and on the right you have the virtual machine in blue, and the privilege goes to the left. So VMX root is more privileged than the right with the virtual machine. And of course you have multiple virtual machines running multiple processes, so now you start to pile boxes on top of each other. Of course, there is a secret mode in your CPU, that's the system management mode, that has been there since '93 actually. This was really introduced for the BIOS and for the hardware manufacturers to hide errors within the hardware and for emulating, for example, USB devices and things like that. And that's what's called the ring -2. Of course, it's not just a ring -2, it's a completely parallel ring as well. So now we have 4 more rings on the left. I'm going to color that with green. Of course, that's not enough. Why not? We can just keep piling layers. So there is actually this secret mode within the secret mode that actually enables a hypervisor to run within the system management mode, and that's what's called a secure transfer monitor. And then on the right, you actually have virtual machines running within system management mode, and I'm going to be using the dark green to signify that's actually virtual machines within system management mode running on a hypervisor that runs another hypervisor that runs virtual machines that run processes. let's add some more. We actually have ring -3. Has anyone heard of the Intel management engine? So what that is actually it's a coprocessor. So this is not actually a ring -3 either. Might not be surprising. It's actually a coprocessor. So this Intel management engine is turned on even if your main CPU is down. We don't really know what is running on it, except that it's some sort of Java stuff, which is kind of unsettling. And it's running on an ARC600 processor, which only has a user and kernel mode, but has 16 of those. And that's the most privileged part of the system. In 2013, nested virtualization was introduced. So that is actually running a nested hypervisor on your main hypervisor, but in VMX non-root mode. So that's a dark blue. And what's coming next is actually the Intel SGX extension that's going to be released sometime within this decade, probably this year, next year, or whenever Intel decides that it's ready. And what that does is actually it carves out a space within ring 3 within your virtual machine, for example, so that you can load something into that mode, encrypt it, and then all of this stuff to the left that is running underneath your virtual machine doesn't actually have access to it. So they kind of realize that we have too many layers now, so you actually have to trust all that stuff that's running on that hardware before you can actually trust that your cloud is secure, so this is what they introduced. And of course, that's available in all of those modes. Luckily, this is not available in system management mode, so it's not that complex. And let's, of course, not forget that we also have ARM CPUs built into all of our peripherals. So to put into perspective, this is what we have right now in our modern hardware. It's definitely not something that looks straightforward. And this is not to say that we are screwed totally, but as you might have seen, this is really has been becoming more and more complex. And when you turn on your computer, it actually goes through that entire process from going from real mode to protected mode and running a virtual machine. So these modes are all supported in every CPU we have today. But for cloud security, really all we care about is just this little segment. So we just have the hypervisor and we have the virtual machines. And let's just look at that. And what we want to do there is to secure those virtual machines using the hypervisor. So instead of using your regular antivirus, which runs in ring 3, we want to move that out to a protected separate box so that it's actually protected by the hypervisor so that we can actually monitor the VM's memory and the hardware and provide some sort of security within the cloud.